Hi, everyone. So today we are going to be factoring a quadratic trinomial. That's where ax squared plus bx plus c. That means a is a number, b is a number, and c is a number. But the highest degree is 2, is what we have factoring, but these are special. It's a quadratic trinomial. Just a hint, this is where we're going to get our quadratic functions from. So this section in particular, 6665, is going to be very important on the factoring because this is the foundation for chapter 8 and for chapter 7. All right, so remember, like last class, if you are factoring out, if A is a negative number, you're going to factor out the -1 before you start. Then you're going to multiply the A times the C term, the first and the last. You're going to find factors of AC that will add to give you the B term, split the B term, and then we're solving by graphing, which is the last thing you did in the last notes. So let's look at number 2. We have 5x squared plus 17x plus 6. It is looking like ax squared plus bx plus c. So A is 5, and B is 17, and the C is 6. That's where we're getting those letters from. When we are going to factor, we have to multiply the A times the C term first. So that's A times C, 5 times 6, and that's going to give us 30. I want to find two numbers that are multiplied to give us 30, but added to give us that middle term, which is B. And that's 17. Now, at this point, it's going to be a lot of you using your noggins, thinking about those factors. So for 30, I know 10 times 3 is equal to 30, but 10 plus 3 is equal to 13. That's not the combination that I need. Maybe you want to think 30 times 1 is equal to 30. Well, 30 plus 1 is 31. That's not the combination that I need. Maybe it's 6 times 5. That's also equal to 30. But added together, that's 11. So that's not it. You're going to keep going until you find it, right? So in this case, I think, let's see, 2 times 15. Yes, 2 times 15 is positive 30. And 2 plus 15 is 17. This is the combination that I need. Now that I know the combination, I'm going to split the middle term. So the first term is still 5x squared. That middle term, which is 17, I'm going to split it into 2x and 15x. And it doesn't matter which one comes first. Then that last term is a plus 6. I'm taking this term and splitting the middle. So 17 becomes 2x and 15x. Now, if you remember factoring by grouping, if I have 4 terms, I can group them. So I'm going to group, let me go ahead, the first 2, and with the sign, the last 2. Now I'm going to see what I can factor out of 5x squared plus 2x. Well, they don't have anything in common with the 5 and the 2, just the 1. This one has an x squared and this one has an x, so I can factor out an x. That means I'm left with 5 divided by 1, didn't use it, x squared divided by x, I took 1 out, so that's an x, plus 2, didn't factor anything out, and then x divided by x, I took an x out, oh, so there is no x, sorry. And I'm done. Let's look at the second parentheses. What can I factor out? Between 15 and 6, mentally I know, 6 is not common, but oh, they could both be divisible by 3. So I'm going to factor a 3 out. That means I'm left with, oh, this one doesn't have an x. I can't factor out an x. I'm good. I'm left with 5. 15 divided by 3 is 5x. and 6 divided by 3 is 2. Oh, lo and behold, look, it matches. Remember, that one should match. If it doesn't match, there's a problem. Something is wrong, and you have to figure it out. So the matching one becomes its own parentheses, 5x plus 2. And the leftovers will become the leftovers. The x and the 3 becomes their own parentheses, x plus 3. I have factored my quadratic trinomial into two binomials. I want us to check it because this is literally the opposite of what we did when we multiply. So let's put a check. So when we check, we have 5x plus 2 times x plus 3. 5x times x is going to give us 5x squared. 5x times 3 is going to give us 15x. 2 times x is going to give us 2x. And 2 times 3 is going to give us 6. And then I would have combined like terms, the x and the x. So then my final answer would have been 5x squared plus 17x plus 6. So this is what we did in class when we multiplied, right? This today is where we're starting, and we're factored out to find out where, what are my two binomials that I had to multiply. This is how you can check your work. If you multiply it back and you get the same answer that you started, you know you're good to go. Let's do another one. What do I want to do? I'm going to go ahead and let us work on number 6. Scroll on down to number 6. I want to do number 6 because in the front of it, there's a negative, right? So I still have ax squared plus bx plus c. My a term is -4, my b term is -13, and my c term is -3. Something weird happens when the a term is negative. So if the a term is negative, you need to factor out the -1 first, or any other number you can. So between 4, 13, and 3, the only thing I could factor out is the -1. I'm going to do -1, and then for x squared minus 13x minus 3. So now I'm working here with my quadratic trinomial, ax squared plus bx plus c. And a is positive. I'm going to go ahead then and do a times c, 4 times -3. Uh-oh, so sorry. Miss Reed did not change the other signs. This should be a positive and a positive, because when I factored out -1, this sign changed as well. Your b sign changed and your c sign changed. I apologize. Make sure we change those signs. Okay, so then we have 4 times 3, and that's going to give us 12. So a times c, two numbers multiplied to give me 12, and I'm looking for the number added. That's going to give me the middle term, 13. Well, how do I get 12? I know there's 4 times 3, but 4 plus 3 is going to give me 7. That's not what I need. Maybe it's 6 times 2. Well, added together, that gives me 8, not the answer that I need. So then I think, maybe 12 and 1. That does give me 13. Good. This is the combination I'm going to use. So yes, my -1 is floating around. I'm going to bring that to the answer because I'm focused on the quadratic trinomial. So I have 4x squared. The middle term, 13, is going to get split into the 12 and 1. So this become a plus 12x plus, I'll put the 1 there, 1x. And then I still have my plus 3. Now there's 1, 2, 3, 4 terms. I'm going to go ahead and solve by grouping the first 2 terms and the last 2 terms. Always include that sign in front of that third term. So now you think between 4x squared plus 12x, what can I factor out? Between 4 and 12, the greatest common factor is 4. Between x squared and x, I can factor out an x. And then I'm going to be left with 4 divided by 4 is just 1. And then x squared, I took out an x, so x. Plus 12 divided by 4 is 3. I took out an x, so there's nothing else left. Oh my gosh, it matches. I know I'm on the right track. So now I need to factor something out to make the second binomial. I'm going to factor out a 1. And then I'm still left with x plus 3. Remember, the leftovers become its own parentheses. The leftovers is its own parentheses for x plus 1. And then the matching one gets its own parentheses, x plus 3. Don't forget, though, in the beginning, you factored out a -1. So there is a -1 out here in the entire answer. I want you to know that's one option. But you might also see it where they apply back the -1. So -4x minus 1, if they distribute the -1, times x plus 3 is also an option. If they put the -1 to the x plus 3, then your answer would be 4x plus 1 times -x minus 3. And that's another option. They are all correct. Sometimes you'll see them ask you, select all that applies. Or they may give you one of them and ask you, what's the other one that's missing? That's because, again, that negative coefficient makes all of these a little tricky, and you can see any of those options. Okay, let's go ahead and we are going to do, I think I want to do 2 more together. The next one I'm going to do with you is number 5. And number 5 is tricky because there are 2 approaches, and it depends on how you want to think about it, right? So if I look at this, I see 5x squared minus 35x plus 50. That's fine. You could go ahead and do your A times C, and then you're going to get 250. And added together should give you the middle term, which is 35. I want you to go ahead, even though it's a big number, negative rather, 35. Right, so now I want you to go ahead and think, even though it's a big number, in order to get a positive 250, but a negative 35, so remember multiplied, and this is the number added, then it needs to be 2 negative numbers, right? Because a negative times a negative gives me a positive, but a negative plus a negative is going to still be a negative. So I'm looking for 2 negative numbers. Reaching into my stuff, let me see, 250, maybe that's 50 times something, so 50 times 5, and they're negative. Okay, so that would give me positive 250, but added together, it's going to give me negative 55. That's not what I want, so I'm going to cross that out. Then I want to think, man, what else? 250 times 1, that should definitely not work, because that's just going to give me negative 251. I could even save space on my paper. Then I want to think, okay, maybe 10 times 25. That also gives me 250. I need to flip those signs because negative 10 minus 25, yep, that gives me negative 35. I am good. So this is my combination. Go ahead, now that you know the combination, pause, and I want you to try number 5. All right, now that you have done it, welcome back. I went ahead. We would have had 5x squared. And we're going to split that middle term into negative 10x minus 25x plus 50. Then I'm going to go ahead and group them. And from here, I'm going to factor out a 5x. I'm going to be left with x minus 2. And then from here, I'm going to go ahead and factor out a 25 because 25 and 50 have that in common. So I'm going to factor out a negative 25, in fact. And then when I factor that out, I'm going to be left with the x minus 2. Once I realize that match, I know I'm on the right track again. So I have 5x minus 25 times x minus 2. Now, we are done, but not quite done, because you see that 5x minus 25, and it depends where they want you to stop. If they want just the by and by, fine. If they want you to factor completely, then we need to go another step, because 5x minus 25 can be factored again. They both have a 5 in common. So I could factor out the 5, and then I'm left with x minus 5, and then I still have that x minus 2. Now I don't have anything else to factor. Now I'm all good. I'm done here, but this can also be an answer depending on the circumstance. All right. So the other way we could do this is, scroll on up. I'm going to write the problem, put it in black. 5x squared minus 35x plus 50. I want to know my t-chart, multiply and add. If I look at this at first, maybe you can see that 5, 35, and 50, they have a common factor of 5. So if I took out this 5, then I would have x squared minus 7 plus 10. And this would be a little easier to work with. I wouldn't be working with the big 250 because 1 times 10 would be 10, and added together would be 7. So now I'm working with smaller numbers. That's an option. The 10 I know can be split into 10 and 1. Oh, has to be negative because that's a negative 7. 10 and 1, negative, negative. It's going to give me negative 11. Not it. So maybe, how do you get 10? 5 times 2. And they have to be negative to give me a positive 10. Negative 5 plus negative 2 is a negative 7. So yes, this would be my option. Then I could go with x squared, split in that middle term into negative 5x minus 2x. And bringing down to 10. So then I would group it, group it, group it, group it, and factor out an x. And I'm left with an x minus 5. Factor out a negative 2, and I'm left with an x. What's that? X minus 5. It matches. So my answer is x minus 2 times x minus 5. And then the 5 from the beginning. So this answer is the same as that answer. Either one would work. All right, I'm going to do one more with you. I know you're like, Miss Reed, can I try it on my own? I got you, I got you, I got you, I got you. I want you to try, I'm going to do number 1 because number 1, there's a problem. If I look, I'm trying to factor, or I can only use this process, I should say, if it's a quadratic trinomial. If it's in the format ax plus bx plus c, a number x squared, a number b, a number x, and a number c. In this case, the highest degree that I see is a 3. That means I can't apply this to that. In order to do that, I need to factor something out first, or try to factor something out first. And so when I look, I see between 3, 15, and 18 divisible by 3. And this has 3x, this has x squared, and this has an x. So I can go back to what I just did the day before, and I could factor out a 3 and an x. They all have the x to give. Remember that process? 3 times 5, 3 times 6. Then I would be left with x squared. 15 divided by 3 is 5 plus 5x minus 6. So now I can go ahead and I'll do my, that's a 1. I don't see anything in front of the x squared. So a times c, 1 times negative 6 is negative 6, and added together is positive 5. So now I'm looking for a combination that will give me, multiplied will give me a negative 6, but added will give me a positive 5. So maybe 2 and 3. 2 times 3. 1 has to be negative, so negative 2 times 3. Well, that gives me negative 6, but negative 2 plus 3 is positive 1. That's not going to be my combination. So maybe I want to do 6 and 1. That gives me 6. Maybe I want a negative 6 and a positive 1. Well, added together, multiply gives me negative 6, but added is going to give me negative 5. I realize that I'm close. I do have the 5 that I need, but this is a negative 5. That means I do have the right combination, wrong sign. So now I'm going to flip it. It's 6 times 1, but I'm going to put the negative on the 1. 6 times negative 1 is negative 6, but this is a 6 plus negative 1 is a positive 5. This is the combination. So now that I know the combination I need, I still again, x squared, stay there, and I split the middle term so that the 5 will be split into positive 6, x, and negative 1, x. And then I have the minus 6. So then when I go ahead and I group, factoring out of here, I can only factor out an x. So then I'm left with x plus 6. And oh, look, it's very close. I need to factor out a negative 1. And I'm left with x plus 6. Because the negative divided by a negative will be a positive. So now we have the leftovers, x minus 1 times x plus 6. And then I have the term that I factored out in the beginning, which is 3x. And here I am. I'm done. I want you to go ahead and try number 3 and 4. Pause and try number 3 and 4 all by yourself. Let's see what we come up with. All right, now that you have paused it, I want you to, or this is your solution. I did 6 times, 6 times negative 5. And 6 times negative 5 is going to give me negative 30. So multiplied should give me negative 30. Added should give me the middle term, which is a positive 7. So now I'm going to go ahead and think of those factors. The factors that would work is 10 and negative 3, because 10 times negative 3 is negative 30, and 10 plus negative 3 is 7. So then that's the combination I would use. You should have 6x squared plus 10x minus 3x minus 5. Now, if you have the minus 3x and then the 10x, that's fine. You're going to get to the same place. Your grouping is just going to be a little bit different. So then you want to group it between 6x squared plus 10x. I know I can factor out a 2x between 6 and 10, 2. And then I will be left with 3x plus 5. And then, oh, that does match. I know I'm on the right track, but my signs are different. I need to factor out a negative 1. So then this would be a positive 3, and that will be a positive 5. So then my answer will be 2x minus 1 times 3x plus 5. And again, to be fair, you don't need me to check because you can multiply to check. All right, so you could go ahead and do 2x minus 1 times 3x plus 5. 2 times that gives me 6x squared, gives me 2x times 5 plus 10x minus 3x minus 5. And then we would get 6x squared plus 7x minus 5. And then, yep, you know you're good. You could check your own work. So number 4, now that you've done it, you should have done 3 times negative 8. Multiplied would give you negative 24. Added should give you negative 2. The combination is going to be negative 6 and 4. Negative 6 plus 4 gives me negative 2. That's it. So this middle term is going to be split into negative 6 x plus 4x. And then, of course, I have my 3x squared going on, and then my minus 8 at the end. We're going to group it. Again, same old process now. 3 and 6 is going to be 2. X squared and x is going to be x. So then I am, oh wait, 3 and 6 is 3. Sorry, I'm moving so fast. So 3x is what we're factoring out. 3 divided by 3, 1, so I'm left with 1x minus 6 divided by 3, which is 2. And that's it. On the other side, I'm going to factor out a 4. And I'm going to be left with x minus 2. Sometimes, again, I look at this first one to help me figure out what the next one could be, right? So then my leftovers, 3x plus 4. And then my matching one, x minus 2. Those are my binomial factors. Now let's go on down into the next side. Please, again, look and notice ax squared plus bx plus c. So every single one of these had a number, an a term, 5 here in number 2. 3 was my a term in number 4. Negative 4. 4 was my a term in number 6. They all have an a term. 6, 5 is actually easier because your a term, remember it's ax squared plus bx plus c. Your a term sometimes is just 1. And if that's the case, things get a little bit nicer, a lot faster. So we see same old process. I don't see a number. That means it's 1. 1 times 8 is going to give me 8, and added will give me 6. Well, that combination, again, I'm still going through the process. What is it? Could it be 8 and 1? No, because that's 9. 2 and 4. Yes, that adds to 6. That's my combination. I'm going to split this. So we have x squared plus 2x plus 4x plus 8. And I am, I think, speaking a little bit faster now that we have the gist. But if you need to slow me down again, please slow me down. I'm going to factor out an x. And so I'm left with x plus 2. And then my other factor, I could factor out a 4 between 4 and 8. So I'm left with the x plus 2 again. So matching x plus 4. And then leftover x plus 2. Well, if your a term is 1, I could actually skip a lot of that because I know that the only thing that gives me x squared is an x and an x. There is no number in front of it, so I don't have to worry about which binomial gets that a term because it's just 1. So if this is 1, then you can use your factors, plus 2, plus 4. You could go right there. Same thing. All right, let's do number, what do I want to do? I want to do number 3. Why not? So if I look at number 3, again, my a term is 1. So it makes it easier. If my a term is a number, like what we just did, your a term is 5, or your a term is 4. Again, you don't know which one gets it. That's why we have to go through the whole factoring by grouping. But if it's by 1, then you know you're good, because 1 times 16 is just 16. And then you know you needed to get negative 10. Well, what could that be? 4 and 4? No? because you know they need to be negative to be a positive number, and that's -8, so that's not it. Maybe 8 and 2, negative, negative. -8 times -2 is +16. Oh, -8 plus -2 is -10. Good. This is my combination. Because your A term is 1, you're good to go. How do you get x squared when it's 1? It's just x times x. 1x times 1x is 1x squared. And so my combination, x minus 8 and x minus 2, I am done. If you want to go ahead and do the whole factor by grouping, like what we did here, you can. Same answer, but this is shorter if there is a 1. Now, the only issue will come here, like number 2, where we see 4x3 plus 20x squared plus 24x. Well, your highest thing is a 3. It doesn't look like x squared plus bx plus c. It's not a quadratic. In fact, it's a cubic trinomial. So I have to factor something out first if there is a problem. So I see 4x cubed, 20x, and then a 24. Well, what can go into 4, 20, and 24? 4 can. Good. And so this has an x squared, and an x3. I could factor out an x as well. So that now I'm left with x squared plus 20 divided by 4, 5. I took an x out, 5x, and a plus 6. This is now a quadratic binomial, which means this is a 1. 1 times 6 is going to go ahead and give me 6, and added together should give me 5. Well, positive 5, what's that? 6 and 1, nope, that's 7. 6, 2 and 3. That gives me 5. Good. So now I know that this can be factored into a x plus 2 and a x plus 3. And you do have the 4x in the front. You need to put that back in the answer. Ta-da! Now go ahead and try 4. No. Oh, I guess so. 4, 4, 6, 5, 8, 9. Try the rest of them. Pause and try the rest of them. Get the hang of it. All right, now that you have paused and tried them, then 1 times 4 is 4, and added together should be 4. Well, I think that's 2 and 2. So your answer is, sometimes moving fast, x plus 2 and x plus 2. And remember to check, you just have to multiply them, distribute. Number 4, I didn't mean to, I think, but it's very good. 1 times 16 is 16, and then you have 9. So then you have, I think you did 4 and 4. Nope, that's 8. We did 16 and 1, maybe. That's 17. What else? Give 2 and 8, 2, 8, 16, and that's 10. And none of them work. Very rarely, please, it's not all the time, very, very, very rarely, no combination work. And so because no combination work, you can't solve by factoring. So this is not factored. Trying to beat the bell. So in the next one, we have 1 times 16, and added should be 8. Well, that's 4 and 4. So we have x plus 4, and then x plus 4. I'm just going to go ahead and put the rest of the answers out. Number 5. Oh, wait, I didn't do it. 25 and -10. -5 then and -5. So this should be a x minus 5 and x minus 5. Number 8, we're looking at -24, and then there should be a -5. Oh, this is interesting because this is going to be multiplied and give me negative. So what's this? 6 times 4. 1 is negative. No, that's going to give me a 2. That won't work. Maybe that's a 12 times 2. That gives me 10. That doesn't work. 3 and 8. 3 times 8. That's negative, gives me -5. Yes. So x plus 3 and x minus 8. And then lastly, number 9. Let's see, Miss Reed, this should be an x and this is an x. It's going to be 5 and 4 because that middle one came to 1. And that's a positive, so it must be a positive 5 and a negative 4. Thank you for watching. Make sure you're taking your notes, and I will see you tomorrow.